Welcome to Introduction to Cisco Packet Tracer, including how to log in, basic overview of the UI and some packet tracer features, and how to create a basic peer-to-peer network. The first thing you'll need to do is create a login, either by searching Cisco Networking Academy, or if you open the program, you can click on the sign up link, which will take you to the appropriate place. Once you've done that, you can download Packet Tracer from the website, and you can also use the login to use the full version of the program. There's also an option down here to keep yourself logged in on a personal computer once you have. So when you are logged in, the first thing that you'll see is the workspace that you have here. So the default is logical view, which if you've used Packet Tracer before, you may have used. We're going to become more familiar with using the physical view. So if you click on physical, it will show you where you are in terms of real life objects, including things like cities. So first thing first is to get yourself used to using the controls to find your way around. You can't drag and move yourself around like this. You can hold the control key and zoom out, which is quite useful. And you can scroll up and down, and you can use the arrow keys as well, actually, to find your way around. You can click and drag objects, such as you can see here I have with this city. So if I zoom out a second, you can see I'm at the outermost layer here. So this would represent something like a state or a province or even a small country. And I can add various elements here, including things like cities. So this is our default city. On the top right hand side here, you can see the elements that I can add. So let's go ahead and add one. When you do, they appear in the top left if you find things that go missing. And so I could add a city here. So for example, this might be Newport, might be Cardiff. And this is important in terms of actual testing the physical distances and quality of signal between various different places. Whereas if you just add things in logical mode, they will appear in a cabinet in the office, which we're going to look at now. If you click on one of these elements, one of these cities, it will take you down a layer. There's the back level icon there. So this is the city with the roads and different blocks. You can see here is the office building. Now again, I can add elements here such as another building. So I might have another office located somewhere in the city. Again, if I click on this, it takes me another level in to the office itself. So you can see the layout of the rooms, the hallway here. This is the main wiring cabinet, which you may have seen in buildings where they keep all the servers and the switches. If we click on this is basically like a small cabinet. And if we add things, let's go and actually go back to logic, and we'll add a router in here. If you add devices, and let's add a PC actually, we'll come back to the adding stuff in a minute. But if we add things in logical, go back to the physical, you will see that they have appeared now in this wiring cabinet rather than in any rooms or cities. So if you just design things in logical, everything will just be dumped inside this room and so it doesn't really correctly simulate how a network might actually function. So that's why we design things in the physical. So going back to adding elements, so as I've already done, in the bottom left-hand corner are elements that we can add. Some might be more familiar than others. So we have network devices, end devices, components, which we won't be using, miscellaneous and multi-user connections. We will be using connections. Underneath each of these you have subcategories. So underneath network devices we have routers, switches, which we'll be using, hubs, which we probably won't, wireless devices, which we will be. There's also physical firewall devices and emulators that we can set up, but none of the things that we will need to be doing. It will become increasingly apparent as you use the program that it is quite a deep and complicated program. It is also a program made for training and for taking in exams in. So it's a little bit like a controlled assessment environment for setting up networks. So you've got, as well as network devices, you've got end devices, you've got PCs, laptops, servers. There's also a lot of accommodation for things like Internet of Things and office sensors and various things that, again, we won't be needing to get to look into, but you can experiment if you want. We have, as I said, connections. If you click on connections, you will see and hover over the different wires, you will see the different types of wires that cabling that we will be using. There is the toolbox on the top left here. Again, we will be using some of the things here. There's ones that you probably might be familiar with. There is the zoom in and zoom out. However, control tends to be much easier. Deleting things can be a little bit of a pain. So if we go into logical mode a second, so it's quite common that you will have something selected. You want to delete something. You switch to delete mode by either clicking the icon or pressing delete on the keyboard, and it will ask you if you want to delete the thing you currently have selected. So you'll have to press cancel, then select the delete thing again, and then delete the thing that you actually want to delete. You can press escape, which takes you back to select mode, which is useful. It's just one of the many quirks of using Packet Tracer. The final thing to show you in terms of finding your way around is the simulation and real-time options. Real-time is the default. Again, comes back to the fact that this is exam software, so you would be given a scenario and you have this clock up here which is ticking, which will basically time you in terms of building a certain network or scenario. The simulation then is essentially a way of running the simulation that you've created, the setup that you've created. We will be using this to some extent if we will be using something called traffic generator, not in this tutorial, but later on, where we will create traffic to simulate messages moving around devices on the network. That we're now going to create the basic peer-to-peer network. So we can get rid of everything there. Select new. So again, we're going to start in the physical view, and we are going to very briefly just sort of set up our environment. So city, we have our office, and we are going to add some devices into our office space. So we're going to start with just a PC over here, and put a PC in this room, and then we are going to connect them. So we're going to use the appropriate cable. You should know when connecting to similar devices, you should use a crossover cable. And if you are connecting PCs to routers, because PCs are effectively routers, or routers are also effectively PCs. So we're going to connect these two PCs together, and we're just going to plug it into the first and only socket there, and we're going to plug it into the socket there. So it is somewhat important that you don't just plug things into each other any which way and have a spaghetti junction across your office. If you right click, you can create bend points. It is a little bit tricky. So there are a couple of reasons why I would want or need to do this. Is the first one being so I know where things are, and if I need to change something or other sorts of maintenance, I don't need to start randomly digging up or making holes in the wall and the ceiling all over the place. If I keep everything organized, for example, along the hallway here, it makes things easier. The other reason is health and safety. If I need to drill a hole in the wall or add lights or whatever it might be, then there should be a blueprint, a schematic of where different cables are. And if they're all in the one place, it makes things easier and safer. So we will be expected to do this. The other thing is obviously, of course, in terms of the actual distance of cables and the small but significant, sometimes significant changes that this makes. Perhaps more so, obviously, when you are dealing with going out from across cities. So we are wiring in the physical. If we switch to the logical, you'll see that here are my two PCs. Now, where things are placed in the logical realm, once you have placed them in physical, isn't always as straightforward, and you will tend to find yourself needing to hunt for devices that you may have added. Which is somewhat better than adding everything in logical and then having to take them out of your cabinet and then place them physically, which would not be very easy. So once you have set them up, it doesn't really matter which mode you're in terms of setting up the configuration. If you click on device, that will take you to the configuration of it. You'll see here that you have various different ports, so you can click on this. Basically, these are different modules that you can add in. You'll need to turn the power off in order to do that. When we get around to doing things like that, remember to do that and turn it back on. You can remove the ports, and for example, the default one selected here was a wireless, so I could remove the LAN and then add a wireless module. There's the basic configuration settings, which we'll be using quite a lot. There's also desktop, where you can have more and better ways of entering information and using various different tools. to simulate and send a different use different protocols between different devices. There's also one command prompt, which is one that we will be using a lot in order to perform tests on your devices to see that they can communicate with each other. These are both exactly the same at the moment, hence the term peer-to-peer. And if you go to programming, again, you can actually enter scripts into the devices. So there's a lot of depth to what we can achieve here. If you just go to the config, which is where we'll be entering most of the information that we'll be using. So what we're going to do is we're going to assign IP addresses to each of these different computers, and then we are going to test that they are able to communicate with one another. If you click on config, the first thing you'll be confronted with here is the gateway settings. We're going to be using DHCP in the future, but at the moment we're just going to be sticking with static IPs. We'll come back to gateways in a minute. Let's first of all set up the addresses for the individual computers. So we're going to be using a C-class private address. So this is an address that starts usually with something like this. So this is our network address, and then we are going to number the host, and this is our first computer, so we're going to number it as 1. When I press enter, you'll see the subnet mask shows me which of the numbers are the network address, and then which one is the host address. Make sure the port is on, which on other devices you'll find that you will need to turn them on before you do anything. And that's it. That's all we need to set up there for the time being. And then we go to the other PC and we're going to do the same. Go to config. And we're going to leave the gateway settings as they are a second. And we're going to go to the Ethernet port we have plugged in. And we're going to set the IP address there as 192.168.0, that's our network. 0.2, which is our device. Press enter. Again, check everything is on, and then we can exit. So let's test it out. So if we go to desktop, and we're going to select the command prompt utility, and we are going to use ping to test connections there and back between our other device. So we type ping and then the address of the device that we want to connect to. So we are the first one, and so we want to connect to the second one. Press enter, and you will see then the information in terms of how quick. And because our connection is so short and there is no a very small number of devices, our ping is extremely low. So I would create a test table, and this is the information that I would be copying in to show that my test is successful. We can then test it the other way around. Open command prompt again. Ping 192.168.0.1 this time, because we're going to ping not ourselves but the other machine. And again, you can see I'm getting replies from the device. So I said that I would come back to gateways. So if we go into the desktop, and there is another way of entering IPs here using the IP configuration utility. Perhaps slightly more informative if I just show you what, if we go to config, you'll see here there is no gateway as such as it says there. If you go back into the IP configuration utility, you'll see that it is telling you that it is actually 0000, which is the local network, which basically means the immediate devices that are plugged into our current device. When we have more complex setups, we're going to need to specify certain gateways. And so we can do that here. So in this case, we are going to specify the gateway as being the other device, just to show that it works. So we are currently on 01, so 168.0.2 is where we want our messages to go. Close that. Do the same on the other side. So 192.168.0.1. Let's just check I entered that correctly. Yeah, 0.2. So the gateway for this PC is that PC, and then the gateway for this PC is that PC. So again, we can check our ping. When you are in command, if you press up, you can cycle through the previous commands you have written, which is useful. Let's test it again. There was a short delay there, you can see. As it does simulate real life to some extent, how things aren't always, might be some small differences in things. Again, let's go and test it the other way. And up again, test. Yeah, extremely quick, less than a millisecond. There. So again, this is information I would record into my test log. And so this brings us to the final part of our tutorial, where we are going to configure a firewall and learn how it can be used to allow or deny inbound and outbound traffic and connections from devices on the network. So for this, we're going to be adding an additional peer. So we can put a PC into this room here. And we are going to need to rewire some of this because the PCs only have one LAN port, as is common, and you can't add new ones. In this case, we are also going to need a switch. So under network devices and switches, a PT switch, we're going to put in the wiring cabinet. It's been added to the table. Make things a bit tidier by putting it in the rack. And then we are going to go back a layer. So from the table, you should know that when we're connecting to similar devices, we use a straight through. So I can connect these here. You'll also notice perhaps that they are green. as opposed to orange, whereas they might not always be these colors. It is common for different types of cables to be color coded so that they can be easily distinguished from each other. Okay, so I've physically connected these PCs up with each other. I am going to now need to add an address to our new PC here. So I'm going to label it using my naming scheme, and then under the Ethernet port label, give it the address of 192.168.0.3. Please also check that your gateways are all 0 for each of these devices. So there should be blank on all of these. And we can now test to make sure that they're able to communicate with each other. One 168.0. So we're on 1, so let's ping our new device. Happens to everybody if I got old firewall stuff on here. Let's try that again. So we can see that at the moment we are able to connect to our new peer. Let's check the other one. Ping 192.168.0.3 and able to connect and receive a reply. So all our computers are configured. So we can now go ahead and configure the firewall. We're going to do that on PC1 or P2P1 in this case, or rather I192.168.0.1. Click on the device and go to desktop, and we are going to configure the firewall. A quick overview of what firewalls are. So they are can be pieces of hardware or software or both that act as intermediary or a wall, essentially, that will then choose what traffic or protocols to allow or deny through. So used as a security device from unwanted users, threats, hackers, etc. I suppose useful note, think about where the word firewall comes from. In the physical world, we would use a firewall to protect or secure devices such as hard drives, for example, from threats such as fire. I suppose also from people by protecting them in secure locations. So it's also important to understand the physical side of these things, and that security in cybersecurity is not purely a digital thing. We also have to think about where the information is physically stored. Yeah, how accessible it is, things like employee IDs and passwords, all of these things that come into securing data for companies. So the first thing we need to do is we're going to turn this service on. You can see that we can configure the service for the different ports in the computer. We've only got essentially the one Ethernet, so that's what we're configuring for. Also useful to understand is the fact that without the firewall, also the default, if you will, is that all traffic is allowed in and out. So that's why we use the firewall to be more selective. So we're going to first show how this works in terms of denying traffic. So we can choose particular protocols. We're going to block the whole IP, so essentially everything from communicating with us. The remote IP is the address of the network or the device that you are concerned with. So 192.168.0 is our network. Now we're going to block everything else on the network as an example first, so it doesn't really matter what we put here. So I'm just going to put 0 for the host. The remote wildcard mask can take a little bit of time to get your head around, perhaps, but it's essentially saying, well, which parts of the remote IP are going to stay the same, and which ones am I interested in changing or inspecting. So we want to keep the network IP the same. So we're not going to change that one, but the last digit there we want to be able to inspect, and we're going to inspect the entire range of numbers there. So we're going to deny all of these connections, and so we add, and then we can go and try it out. So let's go and open up our command prompt here. So we're going to ping 192.168.0.1 from 0.2, and it's not answering us. So our communications are being blocked. Let's go and test the other one here. So ping 192.168.0.1, and we can't connect from this one either. So that is how the firewall works in this case. So let's just remove that, and we are now going to allow one specific device rather than blocking an entire network. I'll just show you very quickly. We can deny everything from all networks. So as you saw there, I denied a particular network. So just very quickly, if you want to just deny everything, then you can do 0.0.0.0 and then 255. This helps to understand how the mask works a little bit, partly why I'm explaining it. So that means I can change any of these numbers here. So that essentially from 0, if you think from 0 to 2555, from 0 to 255, all of these addresses can be blocked. So let's just, again, for proof of concept. So again, I cannot connect with these. I suppose for a more thorough test, it'd be helpful to have different network addresses. So that's to deny everything. So let's just remove that. So I now want to just deny particular, I want to allow, particular PCs on my network to connect with me. Everything else, I want to say, no, thank you. All right. So if I allow a certain thing, yeah, the sort of, if it's not that, so if you think about your sort of truth tables, yeah, so it has to match, yeah, all of the different things. Otherwise, it's just going to say no. So if I choose an allow rule, it is also a sort of deny rule at the same time. I suppose technically, if you choose a deny rule, because the default is allow, everything that doesn't match the deny rule will be allowed. So if I allow, and I'm going to allow an IP, so I'm going to allow our new device, so 0.3, and the remote wildcard mask I am going to put at 0.0.0 because I don't want any of these to be able to be changed. Yeah, that is exactly how I want it to be presented. Whereas before I had 255. However, that would be essentially the same as the first rule I had, because remember I told you it didn't matter what I put there. But now it does. So 0.0.0.0, sorry, and then we add that. So make sure that's on. All right, let's go out and let's test this. So we should not be able to ping from here. So that's being denied because I am not 0.03, and this is 0.3, which I have allowed. So if I ping from here, then I'm successful. And that is the sort of basic concepts of how firewalls work. And that brings us to the end of our tutorial.